Welcome to qnawire.
In this question, we are given that a car in which a pendulum is hanged, the car is moving forward with an acceleration of a, and due to which the pendulum is always keeping an angle of theta with respect to the vertical direction. So in the first part of this question, we have to find the value of theta in terms of the acceleration of the car. In the second part, there is a block which has been kept over an wedge. So the wedge is moving forward in such a way that the block is always at rest over the wedge. So we have to find the angle of inclination of the wedge with respect to the acceleration of the system. So let's first answer the part A or part 1, the first part of this question. So let's say the mass of this bob of the pendulum is m. So m is what? The mass of the bob of the pendulum. Okay, now on this bob, what are the forces acting? First of all, the mg force will be acting downward and the tension force will be acting in the upward direction. And with respect to the reference frame of car, with respect to the reference frame of car, on the car is on the bob, sorry, a pseudo force will be acting in the opposite direction of motion of the reference frame. So ma force will be acting on the bob with respect to car's reference frame. Okay, so then I will write by drawing free body diagram of the bob of the pendulum with respect to WRT, with respect to the car's reference frame So suppose this is the bob. On this bob, the downward force is mg, towards left ma force is acting, and the tension force is acting towards this in such a way that with respect to the vertical direction, this tension force is making an angle of theta. So this tension force will have two components. In the vertical direction it will be t cos theta, and along the horizontal direction it will have the component of t sin theta. So as with respect to the car's reference frame, the bob is at rest, so I will write as with respect to reference frame of car, the bob is at rest. So the net force on this bob will be 0, and that imply along the horizontal direction the ma force will be balanced by t sin theta, and along the vertical direction the mg force will be balanced by t cos theta. So by let's say this is my equation number 1 and this is my equation number 2. By dividing 1 by 2, we will get that a by g is equal to tan theta. This is from 1 and 2. It's very simple. Just divide equation 1 by 2, we will get this. So from here I can write that theta is going to be tan inverse a by g. So this is the answer for the part 1 of this question. In the second part of this question, suppose this is the block of mass, let's say small m, which is been kept over the inclined plane. The angle of inclination of this plane is, let's say, theta, which we need to find. So the condition for this question is that for this part is that this block is resting over the uh, inclined plane. As all the surfaces are smooth, so usually the M block will try to slide downward along the inclined plane. But if we want that this M block should not slide, then the inclined plane should have an acceleration of A in the forward direction, so that this small M block will be resting over the uh, inclined plane. Okay, so if in that case we can just write with respect to with respect to a reference frame of the inclined plane on the block, a pseudo force will be acting backward. A pseudo force of MA will act backward. Thus, if we see that all the forces acting on this small block M, then its weight would be acting downward, which is mg. A normal reaction force will be acting on this block along the perpendicular to the inclined plane, which is, let's say, n. And as I said, a pseudo force will be acting on this block with respect to the reference frame of the inclined plane, and that will be m into a. So if we just draw the free body diagram of the block, so FBD of the block, if we want to draw, then we have to replace the block first of all by a point. On this block, mg force is acting downward, and then a pseudo force of ma is acting in the backward direction. The normal reaction force is acting n along this, and if we look carefully, the normal reaction force is making some angle of theta with the vertical direction. This angle is theta. So then we can take the component of this normal reaction force along the vertical direction, that will be n cos theta, and the component of this normal reaction force along the horizontal direction, that will be n sin theta. Okay, and as with respect to uh, the inclined plane, the block is at rest, so we can say um, the net force on the block will be 0, which imply that along the horizontal direction the ma force will be balanced by n sin theta. So let's say that is my equation number 1a, and along the vertical direction the mg force will be balanced by n cos theta. So let's say that is my equation number 2a. So from 1a and 2a I can write from 1a and 2a, we can write actually by dividing 1a by 2a, I'll get a by g as tan theta, or theta has to be tan inverse of a by g. So this should be the angle of inclination for this inclined plane.